This is our z-axis. This was the x-axis, and this was y-axis, and your loop is the name was O A B C O. Fine. Direction of current is clockwise. Yeah. Each side is length and a magnetic moment here. We can take current times BC vector cross CO vector. And how much is BC vector? Side length is L. And see, its direction is opposite to the direction of z-axis. This is the direction of positive z-axis, and in positive z-axis you have unity vector k cap. So the unity vector in the opposite direction means in this direction, along negative z-axis is minus k cap. So you can write this as L. Similarly, see the CO, this side CO side is making 60 degree with the x-axis, 60 degree. So we'll have to resolve here this into two components. It is making 60 degree with the positive axis, x-axis, and that's why we can resolve it into two components. Two components. Its x component will be L cos 60, and C the unity vector. In this direction you have unity vector I. So in opposite direction, in opposite direction you will have a unity vector. See the arrow here, so its x component will be x component will have direction opposite to this direction. So we write here minus I cap, and similarly now the y component, y component will be L sin 60, and here also we have to take the unity vector minus j cap. Had the arrow been like this, then if the OC vector would have been like this, if we would take OC vector, then see both component x and y component would have been positive. But since we are taking CO vector, its direction is like this, so it's y component and the x component both are negative. In this direction you have a unity vector minus I cap. So in opposite direction, so in opposite direction you will have a unity vector. No, it is I, then it will be minus I. Similarly, in this direction, this is your y-axis, you have unity vector j cap. So in opposite direction, see the direction of y component of CO, it is opposite, and in opposite direction you will have unity vector minus j cap. That's why we can write like this. So it will be how much? Minus 1 by 2. Or you just write L by 2 minus L by 2, L by 2, I minus and the sin 60 is root 3 by 2 L J. Are these clear? If not clear, I will again I will just draw a diagram and explain. See, this is your positive y-axis, and this is your positive x-axis. In this direction you have unity vector j cap, and in this direction you have unity vectors I cap. I cap. And your CO vector, is this one. Your CO vector is this one. It's we can resolve it into two components. Its y component is this side, and the x component is this side. No, but see the direction of x component. It is opposite to the direction of positive x-axis. So if you have a unity vector I cap along positive y-axis, it will have it's in a x component will have unity vector minus I cap. Similarly, you have unity vector j cap in this direction, means it in a y component will have a unity vector minus j cap. Is it clear or not? This direction thing. Good. Now, what we have to do, we have to simply take this cross product. You have current, you have, you just find the L. L, K cap, and your BC side is this much, and your CO side is minus L by 2 I and minus 3 by 2 J minus 3 by 2 J. Now you can take the cross product. So how much will be it? See, minus minus plus k cross I is you can k I is a k. This k cross I is j, and the magnitude is 1 into 1 by 2, 1 by 2 j, and here if you multiply minus minus and a plus k cross I, now you have I cross k cross I, fine. Now you have k cross j reverse order. So k cross j will be minus I. K cross k cross j will be minus I. So you have minus here, and 1 by 2 means root 3 by 4 j. And you had L, in both you had L, here also 3 by 2 L, so L, you will have an L square here, and also an L square here. So you can take an L square common, we have IL square. You can also take 1 by 2 common, then how much will be left? J minus root 3 by 2. This was just wait. Here we made a mistake, I think. See, I, and in bracket you have if you multiply, then it is plus, and L is L square, that is fine, and k cross I is in a j, L square by 2, okay, and k cross I is in a j, And then if you multiply this minus, minus will be positive. But if you take it in the cross product of K cross J, K cross J, will be, minus I, K cross J will be minus I. And here you have 1, so you have root 3 by 2 L square, and you have I cap. So you can simplify this one. See, IL square by 2 will become, here you have a J cap, and okay, yeah. And here you have in a root 3, I. This much is left. This is your answer. This is our, we just have to take cross product, and we follow this for you might have studied in a vector I cross j is k, j cross k is I, and k cross I is j. If we go in this order, clockwise order, we get a positive value, means j cross k is I. But if we go in reverse order, like k cross j and minus I, so it might be clear. Is it clear? So let's save this one and clear. And then let's move to magnetic torque experienced by a current carrying loop in a loop in a uniform magnetic field. In a uniform magnetic field. In a magnetic field. Or we just write field. We have a loop, current carrying in a loop. This is z-axis, this is y-axis, and this one is your x-axis. Z-axis, actually in a positive z-axis. This one is positive in a y-axis, and this one is in a positive in a x-axis. And we have we have a current carrying loop here. We are taking a rectangular in a loop. We can take a loop of any shape. For calculation, let's take in a rectangular in a loop. And let's change the color. Suppose we have for let's take a straight line. We have a rectangular loop here. Let's name it. This is suppose O. This is A. This is suppose let's take in a C, D. And it is carrying a current. Let's make it in a bit like this. Okay, this is our current carrying in a loop, and let's assume the direction of current. Suppose a current is, and let's take anti-clockwise there. We can take any direction. We are taking an anti-clockwise here. And this side is A, and this side is B. So your OA, OACDO is a rectangular loop. It is a rectangular loop. And suppose we have a magnetic field here, and we have a magnetic field here, and it is expressed in component form, and it means BXI plus BYZ plus BZ, BZ and a K. We have a magnetic field in this region, and we have a loop and containing a rectangular loop, having current in anti-clockwise direction. Now we have to find out four things there. First, we'll find the net force on the loop, and the second thing, we will find your torque experienced by the loop. Let's find first force, net force on the loop. Net force on the loop. So this F is means we have to find four forces here. Force experienced by this force experienced by this force experienced by CD arm, and force experienced by DO arm, and net force will be vector sum of these forces. So let's let the force experienced by OA arm FOA, then force experienced by AC arm, FAC, then your force experienced by DO arm, AC, then let's first write force experienced by CD arm, and then force experienced by DO arm. These are net force will be vector sum of these forces. So what about this force? You have studied force experienced by a state conductor in a uniform magnetic field, and in a uniform magnetic field is how much? F equal to how much? I L cross B. We study this, and we will use same thing here for OA arm. What we can write, current times how much OA the length of this arm, OA cross B vector. Similarly, you can write here AC, force on AC arm will be current times AC vector is the length vector cross this magnetic field. Similarly, on CD you can write I CD vector into B vector. You may know not why didn't I write here B, because if you write a B here, you may get confused, because we are writing in a B for magnetic field. That's why I didn't write here in a B. I wrote directly in a C here, and CD, and the last is your force on DO arm. That will be current. Current is same in each arm. Current, and in bracket you have length vector and a DO cross magnetic field. See, you can take I common. You can take I common, then you have OA cross B, then you have AC cross B, then you have CD cross B, then you can write DO cross B, and see here you have B everywhere. In each term we have B. So what we can write this one, applying the rule of property of cross product, we can write OA vector plus we can write in a AC vector, plus we can write in a CT vector distributive property. You can recall you might have studied in a distributive property in vectors. We are applying the same thing plus in a DO vector and now you can write cross in a B. Isn't it in a distributive property? Now you take cross product of its term, you will get the same result. Is it clear up to where? Now see, now tell me, what will be the value of this quantity? This bracket term, OA vector plus AC vector, See, this is your OA vector. And what about the CD? See, OA vector and CD vector have same magnitude but opposite direction. So these two will cancel out. Similarly, see here, your AC vector and DO vector have same magnitude. Magnitude is B, both have or length in B. May have same magnitude. It is rectangular, so opposite sides have same length. No. So see, AC vector and DO vector have same magnitude B, but their directions are opposite. So this term and this term, these two will be cancelled out. Is it clear? Yes or no? So what will be the value of this bracket term OA plus AC plus CD plus DO? The value of this bracket term is 0. So you have I into 0 null vector cross B. So your total net value will be how much? 0. 0, or simply you write F net is 0. Means net force experienced by a current carrying loop is 0. Okay. So is it clear up to now? So let's save up to the this. Now how can we calculate how can we we calculate the torque? Let's clear this now. I will just give you a hint now, and in 5 minutes we will complete this topic tomorrow, and then we have only 2 topics left in this chapter. See, you calculated the force on each arm. When we calculate the force experienced by a wire, by a straight conductor, and if you say the force in this wire is F, magnetic force is say F, this means what? This means the force, the average force acting on the midpoint of this straight wire. So OA force acts at the midpoint of your OA. Similarly, your FAC force, FAC force acts on the midpoint. By FAC force, we mean the average force acting on the midpoint of AC. This in ACR. So the force here Oh, okay. So this side was in B. Okay, that's fine. And by say this is the midpoint, of this side. It means your FAC force will act here at the midpoint of the AC arm. Similarly, your FCD force will act on midpoint of CD. And let these points be, let this be, let's send the color. Let this be E point, this be an F point, and this be G point. Now, what is torque? Torque is almost R cross F. So we'll find torque due to each of these force. Your force is your FOA force is acting at E point, and it's in a distance from O is OE. So what we'll do, first we'll write the values of FOA force. We'll find out separately FOA force. Then we'll find FAC force. The net force is 0, but if you find the value of individual force, force on this arm, OA arm, the force on AC arm, force on CD arm, force on DO arm, it will have some value. But when you find the net force, the resultant force on the loop, that came out to be 0, and we saw that. But in order to calculate, the torque, we need the force, the value of the force on each arm, and we'll calculate, the torque due to each arm, and we'll just add them. So tomorrow, what we'll do? We'll find the value of force on OA arm, force on AC arm, force on CD arm, and force on DO arm. And then we'll calculate the torque using this formula. See, your force is your OA force is acting here, and its distance from the O is OE. How much will be this distance? The side length is L, is L, is A, and E is the midpoint. So OE will be how much? A by 2, and the unity factor along this direction is I. So we can write similarly the value of OE, OEF, OG, and here H midpoint of your DO side is yes. So first we will find out the individual forces, and then we'll calculate torque due to each force about O, and add them, then we'll get the value of the torque. So tomorrow we'll in 5 to 10 minutes we'll calculate torque, and then we have two more topics, one galvanometer, and one we'll study about this moment of electron in a circular orbit. So with after completing these two topics, we'll wind up in this first chapter and moving charges and magnetism. So this much for today. We'll calculate this tomorrow. Okay.